Hello, everybody. Good evening. How are we doing? Trust well, good. Sorry, I'm log into uh, trying to log into YouTube on my phone so I can get a look on our comments. Good evening, everyone. How was our day? Hope our day was great. Good evening. Good evening, Fadike. Good evening. How many are we? We are 19. Let's just wait a bit for others. Let's wait a bit for others. Good evening. Good evening, Akinwali. Good evening. Good evening, everybody. Good evening. Good evening. Yeah, good evening. Good evening. Good evening. So I think once it's like 7:05, right? I just want us to have a very good number so we can just kick start. Yeah, good evening, Shegun. Good. Yeah, good evening. Um, well, today's class is going to. It's going to be an interesting one, and I really hope we went through the materials that were shared. Right, I'm not expecting that we have like that we probably like have it all done in depth, but hope we shall read through them because to give you quite good insight, right, of the whole Gen AI, machine translation, and even application of of both RAG and machine translation and audio together. So, and for those of us that said, oh, they could not access the link for the initial paper. I hope now they have access to the paper now because I sent the physical copy to be shared with us. So I really hope we have access to the paper now. I hope we have access to the paper now. I have to dim my screen a bit though because I have boil in my eye, so I can't really look at screens for a long time. I can't really look at screens for a long time. So just in case, right? Please, you have to bear with me. The eyes are really itchy. I think I need to get an anti-glare glass. Sorry about sorry about that. I had a call. I had a call I had to pick. Good evening, everybody. Okay. Um, I guess we have we are 39. Let's see, because I would not want to start and everybody start telling me, sir, we need a recap. We need a recap. Good evening, everyone. So I guess when we are like 15 class, we will just kickstart. We'll just kickstart, right? But just a bit of housewarming, please. I hope we all read the paper. I hope we all had access to the paper because I know it has been shared to us on LMS. So I'm sure we all had access to the paper. But I hope we read the paper. I hope we read the paper. My eyes are already tearing up. I hope we read the paper. Good evening. Oh, we're 50. Okay, so I really hope we read the paper, right? Because it gives you a very good like use case. And I mean, we might have to, do like maybe real life use cases very soon, where we'll combine all these things and we kind of build our own application, right? It will make so much sense. That I mean, build applications that we can also share on like on our socials. Who knows? Even all these applications can sort of like turn to a startup, right? Because I mean, the future is AI. Everybody's already engaging, into building AI tools, AI softwares. So it would be nice, right, to have everybody, um, build something great. And also, if this kind of stirs your interest in research, then sure. If you want to fine tune your own machine translation model, I mean, take the existing one, fine tune the already, take the existing one, then fine tune it to your own data to make so much sense. I guess that would be very great. That would be a very um great one for us to do. Right? So let me just share what I have here. I'll just share my window. So basically, we're supposed to continue with machine translation, right? But um, sorry, okay. We're supposed to continue with machine translation, but we will just start with the pigeon that we talked about. Sorry, let me turn off my camera so everybody can see what I'm sharing will be visible. Please let me know when you can see my screen. Let me know when you can see my screen, please. Good evening, everyone. Good evening. Please just let me know when you can see my screen. Not yet. Okay, no problem. All right, let's just give it data. It's still blank. Hmm. Let me try it again. All right. I'll try again to share. So how about now? Yeah, it has to be sharing now. Nothing on the screen. Interesting. Let's just give it this. Okay. I'll try it again. Well, I mean, I'm supposed to. What's going on? Stop sharing. Share. Yeah, please. I'm trying to share my screen, but I don't know why it's not coming up. It's supposed to come up. I still don't know why it's not coming up. Mm. So I don't know. I want to assume it's not even the network per se right now, because network is great. Yeah, I'm trying again. I'm trying again. Okay, I think it's back now. Okay, I think. Please, can we see my screen? Oh yeah, I think it's back now. How about now, guys? Can we see my screen? Oh, it's up. Okay, nice. Thank you. Thank you very much, everybody. So today we'll be looking at tokenization, especially when it comes to machine translation. Sorry, is it showing now? Okay, it's showing now. So we'll be looking at tokenization when it comes to machine translation. But before that, right, we were having conversation on we're having conversation on the model I did for pigeon, which was centered around biology or science data, data sets, data conversation, data papers that had to be that were converted to pigeon, and I used that to fine tune a model, right? So that was what. Yeah, I'll zoom in. Okay, I think this is great. Yeah, so I've zoomed in. So we're having conversation on that before we ended the last class. I want to assume some of us had already, gone through the notebook, right? So my job would just be and kind of seeing how they can even improve on the translation. Maybe even test other translation models, right? Because I mean, this notebook will be running for the 6 weeks. Sorry, for week six rather. Apologies. So just to kickstart, right? I'll have to let me connect my notebook. Again, I hope we went through the documents that was shared with us. I hope you went through. I hope we went through that. I hope we learned a thing or two. So now that I hope we learned a thing or two. It looks like nobody actually went through it though. Did anybody go through the document that was shared with us? Did anybody go through the documents that was shared with us? Please, it's more than just coming here, listening to me talk about codes and all that, or having all those materials. If you're not reading those things, you would not know the impact or the real, or you will not have like the in depth of what each of those things do, or the real life application of the tool and all that. Not yet. Okay, please, guys. I understand it's a busy week. I am not putting any pressure on anyone. I honestly do understand, right? But please, please let's go through it. It doesn't have to be till we have like an assignment that we'll now have to go through that. And of course, if you need like the interesting thing, all those things can actually be put in Note LM, and Note LM will turn it to like a podcast for us to just listen to and enjoy. So maybe we are just even moving on the road, we'll be able to listen to it and just it will just be fun. It should just be like listening to your usual audio, right? So please, there's really no excuse, right? If you're intentional about something. So I've connected my notebook, and I'll just have to reinstall all these packages again. I mean, it's essential to do all this so that we'll not be running into bugs. I understand that we are really busy, but just let's make sure we do this. So of course I'll just go and install um the packages I will be using. That's the transformers data, then data set from working phase, Sacred Blue for evaluation. Although evaluation would come in, I think Wednesday, right? And Jumobi will be handling that. So of course um I'll be installing the necessary packages. This T kind of is a library called PyTorch. It's usually for like when we are doing things that involve deep learning and neural network. Then of course the remaining one, the auto tokenizer, the auto model for sequence to sequence LM. This is basically just the transformer. This is the transformer model itself in quotes. That this is the transformer model in quotes. This is just for tokenizing. Be it any model we're trying to use does not have its own tokenizer. We can just use the auto tokenizer to kickstart. So yes, of course this one is just for evaluation. Um, Let me just put evaluation of the. So and yeah, and CUDA, which is our GPU. That's what we'll be using to run this. I want us to do this. This one is just for us to go and read up on, check. Why do you? Why would you usually use the GPU, the CUDA, to run neural network, any project that has to do with neural network? Why not CPU? Can anybody answer on the live chat? Why do you think we do that? Why do you think we do that? Why do you think? And I mentioned it. I mentioned it the last class, but I'm asking again. Why do you think we do that? Anybody wants to answer? I people should not for my hand. At least I would need a response on that, please. Good evening. If you're just joining, good evening. I'm waiting for our responses, please. Why are we using the GPU CUDA to run our neural network? It's not like we cannot use the CPU. We can use the normal system RAM. But why do you think? Oh, the question again. Why are we using GPU, the CUDA, to run neural network tasks? Why not CPU? It's not like you cannot make use of CPU, but why do you think we make use of GPU? Good evening, everyone. Good evening. So, why do you think we use that? Nobody wants to answer. Yes, thank you very much, Benjamin. Thank you very much. Yeah, I mean, okay, interesting one, Omotosho. Interesting one, Omotosho. I mean, ideally, graphics processing units, you use it to display graphics, which was its real intention. But over time, it was now like of known it became known that GPUs could, because initially when Nvidia AMD, when they started building GPUs, it was really for graphics intensive tasks that had to do with games, that had to do with maybe Photoshop, design, product designing and all that. But over time, right? Over time, it had to do with it had to now do it because they saw how good GPUs were actually for running computational tasks in parallel, right? It doesn't like it does like mathematical calculations in parallel, meaning that it can run very fast without having to rely so much on the CPU. It's yes, it can, but it takes time. I'm trying to look for the word. More like a rate limiting step in quotes. Like it takes time before one has to be done before one can actually like finish up a task. But for GPUs, things easily just run in parallel. So that was why. Okay, I will please let me just finish up. That was why the use for GPU the use of GPU that became known for um let's say compute intensive tasks. Even before, okay, I won't say before AI because of course, I mean before let's say before the large language models. When it comes to like neural deep neural network tasks, GPUs were used. I mean, when you want to run CNN for image classification, image generation, audio generation, all these running on your typical LLM. Sorry, all these running on your typical neural network, even the um, before the old LLM pre-trained models came to be. GPUs were the best. It's just that over time, I mean, GPUs now became because of that. I mean, to run very big, to train GPUs are what I even use to train all these large language models. Like so, um, from there we started talking about from T4s to H100 for H100 E100. Like there are a lot. There's even I think one Blackwell GPU that Nvidia has that they commissioned for OpenAI. So yeah, because of that, that's how we started using GPUs for anything AI because I mean they help to make things faster and run in parallel. Yes, I mean good. So yeah, speed and memory space. Well, I would say for speed yet, but for memory space, yeah. The load will be on Collab instead of our system. It's still our system. Remember that we're running this code in the cloud. Please, Mr. Bash, kindly take how to. Okay, so it's just by clicking on this runtime, then you change your runtime, then you just click on T4 GPU, and that's all. And once you are done, you save. So Olufunke, I hope that was clear. I hope that was clear. Well understood now. Is this the reason computers now have every graphics card? So yeah, I mean because it all depends on the tax. It all depends on the tax you are trying to do. So when you see most computers now, most laptops, when you see them like they have like very good graphics card, like good GPUs, it just means that they are very. It just means that they are very good for they are very good for any graphic intensive tasks, any task that involves compute. Even when you are running locally and you have a GPU, you can connect you can install the CUDA package to be able to make use of the graphics card on your system. You can do all that, right? It's all so it's more than just for gaming, for Photoshop, for things that have to do with when you have to spotlight the pixels and they have to render very well. Now you now move it to for AI itself, for AI building itself. Interestingly, crypto even saw a very good major use or in the like for graphics card, right? So I like to gist though. I mean, I like because all these things just makes they make us understand the reason why all these are even set in place, right? And trying to consider people that I mean that might just be kicking, might not really understand the reason why are using certain things like this. And yeah, so for crypto, because crypto also is compute intensive, it's all about the math, so to say, right? So for crypto, you would all I mean crypto during the 2020s, it was almost like anybody that had a lot of GPUs were like the big boys in quotes because like for that's for crypto mining, please. for crypto mining. So you could mine, you can mine crypto with GPUs and all that. Sorry, I'm just joining. It must. Is it they must have a graphics card? No, sorry. Maybe you should go back a bit. You would understand why we're having the conversation on graphics card. One would have to check the system for extra gaming and higher graphics card before attempting that. Yes, and the reason why, I mean, it's I'm right now because of the old boom or the old need for graphics card. It's not really now necessary for you to have a laptop that has graphics card in it. You can have all these things on. You can have all these things running in your. You can have all these things running in cloud. Just as we have here, we have collab. There are even some platforms that they rent, they rent GPUs, they rent compute for you to use, right? So you don't even have to have all this. You can just, you know, go on the cloud. Even people, companies that provide infrastructure as a service, like the AWS, the Azure, the GCP. They already have all these things set up. It's just for me to, just subscribe to it and use, right? So, sorry, Shego, what do you mean by post-it cloud? So yeah, that's like the whole gist about that, right? So I'll just go to what I said we are going to talk about today, which had to do with the pigeon model. So basically, like I said, like explained, this was done using data set that had biology research paper, scientific research paper, so to say, all translated to pidgin manually. And of course, I'll be connecting this to my GPU, then also just adding a bit of debug statement to show that yes, this is to be connected to my device and print the device that is connected to when available, which is my GPU CUDA. Then the tokenizer, that's the auto tokenizer. So I didn't train like a special tokenizer for this. So this would also make use of the auto tokenizer. Peradventure, I had my own special tokenizer. I mean, that would have made it better, right? But it is what it is. This was just a project for fun, right? The PG model, of course, you can see it's an auto model sequence LM, then put it to the device. But this was actually pre-trained on the MT5. So I would just want to show us how the MT5 is. So the MT5 is a Google model that's available on Hugging Face. You can pre-train your own model. Please, just in case we do not cover pre-trained models, right? Please, I want us to like see how we can train our own models. So I just want to show us the MT5. So this is the model card. I don't have this updated, unfortunately. I'm very like this was more of a an hobby project. So I didn't really document it, to be very honest. I didn't have it all documented. So if I just want to show us the MT5. So this is the MT5 model, and you can literally see what people have done with the MT5. You can see the languages that have been trained on the MT5. Like you can also see how people have fine-tuned models on MT5. Basically, we call it T5 model. So you can see it's a lot, right? A lot of people. You see their project that they've used on T5. You can even see any inference available. Yeah, basically. That's that about that. I just wanted to show us that. I tried running hello, how are you, NLB, and it's telling me name error, NLB token is not defined. So it will tell you that probably because you did not import all this. First off, remember you have to install the packages, then now import them. So I'm sure when you do that and you run it again, it should work. Achievers, just in case we don't, we must. Okay, we'll look into that. But that I mean, it's sweet to say, but that's more advanced because that would even involve you guys even having your own data sets. You know. But it would be nice. I would love to see people, take up the challenge to get. I mean, you can get different data sets from different data. So just see what it feels like to fine tune models. Well, just see what it feels like to fine tune models. I mean, and it would be great. So after plugging all this, that's the tokenizer, the model, then now the function to translate and the function to translate to pidgin, all set to all set to 64. Then remember, this is just to wrap the text that I'll be putting in. Then this is what goes into the tokenizer, right? This what goes into the tokenizer and the return tensors. This TP, yes, I remember I did not explain what TP means. So this TP is basically just telling it that it is actually PyTorch that is running that is generating the tensor. Ideally, sometimes that's why basically I'm not importing NumPy because NumPys are what we use for numerical computations in Python for especially when it comes to data science. But PyTorch already has all these things pre-installed. Python already has all these things pre-installed. So, Achievers, I hope you've been able to fix that bug though. I hope you've been able to fix that bug. If you're done, just put it to me on chat. So, yeah, so PyTorch already has all that pre-installed, and it's just for us to show that yes, I mean the return tensors Python that is handling that. Therefore, padding and truncation. So I like I had explained after the entire section, we have access to the learn life system. You have to um I think the organizers will reach out to you on that. Godwin just returning from work. Oh, well done. I would assume that you are based in Lagos, Godwin, because I can imagine. So, so for the padding and the truncation, all set to true. Padding is basically just to help to. I'm getting this one in because I have not started using the GPU, but I'm sure once I run this, they all go to the GPU. So padding is basically just to help like keep the tokens, short and proper, right? I explained that in the other video, so you can just watch. You can just watch the other section to see. Therefore, the truncation, and if you don't still understand, right, please just let me know. Therefore, truncation, that's when just to avoid excessive long tokens being generated. So the truncation helps with that. So okay, why I have this avoid truncation one is because I was when I was running this initially, it was giving me like a very weird warning. So I just had to put this out. Okay, when to avoid excessive long tokenization, maybe especially for repetition, just set it as 128. Set the token as 128. So so like I said, this handles the encoding. Now this has to now do with the decoding, right? So and why this is here for the no repeat engram size repetition penalty. So the model will tend to hallucinate sometimes, right? So or just not hallucinate right now. Hallucination is not the word, but we might have to like start generating things that we are not really interested in. And just to limit, this is the output of the error tokenize 6 input tokenizer. It just basically means you're not installing something right. Sorry that I am going back, guys. But achievers, let me finish. I'll explain that. I'll still kind of go back. But just make sure that you run everything. If you run everything, it's supposed to work. You download the tokenizers and when you import them very well, it should work. I mean, this was something we all did yesterday. Okay, so to prevent the repetition and repetition penalty, that's why all these are here. So maybe if it's kind of maybe when it's generating like extra tokens and I'm saying repetition of maybe say D or A, so it will help to prevent that, right? Then the decoder. Remember we talked about encoder, decoder, self attention. We had looked at that already, right? We've already seen how that should work. We've seen how that should work. And so now this quick sanity check is just to test the model. So let me just remove this and I'll just paste this copy. I just want to, so I'll run this now. So it's going to download my model. It's going to download my model and all that. Truncating using phone. Sorry, Oyemi, I don't understand what you mean, please. So it's downloading the tokenizer special token map, the model itself. So achievers, please make sure you go through. When I finish this, but you should have all the packages installed. Then I mean you won't get that error. That NLB underscore tokenizer just means that the NLB tokenizer is not installed well. So there's something wrong. So to test my model, right? I this is my source language. Then my target language is Pigeon, of course, because that's what this was trained on. So if I click on run, I'll see English and the main unit of life. Can someone give me in the chat maybe something scientific, maybe like a scientific sentence for me to translate to Pigeon? Can someone give me that? Can someone give me that? Anybody, guys, please just drop something for me. Let's test the model together. Just drop a sentence, please. Please. This has to be interactive. Matter is life. Any longer one. I think not too long, but at least a sentence that is kind of longer. Let's try matter is life. But please, I'll need like a longer matter is life. I'll expect matter and life or something related to that. Exactly, matter and life. Entropy is the randomness of a system. Oh, I like that. Okay. Other ones can come true. Entropy is a randomness of the system. So let's bring this. Let's say okay, look at it. Entropy now the randomness of the system. So you see how the model works. How can I be a good coder and make money with it? I mean, a good. This is quite funny. Sorry. Of course, God is the greatest, but we need something more. I mean, more scientific nuanced. How can you be a good coder? Oh, practice makes perfect, right? Practice makes perfect, and the more projects you do, the more you learn with projects. The more projects you do, the more you get an answer on functionality and how to and how to code and what they mean and all. Funny how now we now have Gen AI to help with coding. Then, as at then, 2018, 2019, while I was learning Python, there was no Gen AI. It was all strictly YouTube and Stack Overflow. So they help. But now, I mean, it's easy to learn coding. How do you make money? Is just how you make money from every other skill. How do you market yourself? That's as simple as I can put that. So photosynthesis is the process by which plants are converted. I like this one, and I like the other ones about speed. Let me try the one of photosynthesis. Let's see. Photosyn Photosynthesis is the process by which plants convert sunlight into energy. So let's see how that performs. Okay, so photosynthesis na the process wey plants dey turn into energy, but it misses the sunlight part. So that means there's something wrong with the translation because it's missing something. It's missing something here. Maybe if we increase the uh, new tokens, right? Maybe that would help. That will help it. But I'm trying to prevent. I don't want any issue with with bugs right now. But that should help actually for it to generate something very long. But the sentence is actually sorry. Um. Okay. No, no, no. You said I should write the sentence. so, so Simeon, how can I be a good coder and make money? How does this sound scientific? To be honest, come on, Abba. Let me try this speed. Let me try the one of speed. Let's see how that would work. Um, speed speed is defined as the distance as the stride per unit per unit time. Okay, so let me run this and see how it goes. Okay, speed they defined as the distance where they travel per unit. It didn't complete the time. So my assumption is maybe to just increase the max token. Let me see if I can increase it to 200. Hopefully that should work. So I'll run this again because it's supposed to generate something longer for me. That's what I want. Then let me see. Let me run this. Still the same. Interesting. Okay, let me see. Let me increase this to 120 for 120. That should be 180. Yeah. Okay, so let me set this to 180 still. 128. All right. So let's see. That should work well. Because it's missing some sentence, it's missing some words, some tokens are not rendering back. So that's why it's not giving us like at least a complete like for this time now. I mean it's supposed to give us for time. Still the same thing. Interesting. Okay, let me see if I can. But basically those are the things that maybe I'll have to I think because I already downloaded the tokens and I already set them already. Then I have to delete the runtime and start over again. But that should help with me getting the full sentences back. At least this per unit time should this time supposed to reflect here and it should not be shortening it for me. How many type of races in the world? Really having issues loading the material in collab, getting errors. Sorry, Dmax, what kind of errors are you getting? I asked a question and this is what I got in English. Empty to stop. How do I perform quantum jump? Yoruba. Báwo ni mo ṣe lè àtúnṣe or start hallucinating. Sorry, the universe explainer. Was this for the NNLB? Is this supposed to exactly? So now, because of those repetition, that's why we have this set. That's why we have this set. It helps to, although I didn't put the repetition code, that's why we have this set, like the kind of repetition that should happen, and the repetition penalty. That's why we actually used to set this when it comes to machine translation tax. That's why we used to set this when it comes to machine translation tax, right? So how many races are in the world? I don't know. D-Max, I'm still waiting for you to tell me the errors you're having in the material. How about the rate of chemical reaction increase when temperature? Oh, I like this. Maybe because I'm a fan of chemistry. So let's see. Although this is long, but I'm open on the model um translating this for me. Chemical. So the universe, please, is it the NNLB model that you're trying to run? Let me know, please, so I'll look into that. Chemical reaction increases. I did not modify. I don't have a modifier. Sorry, come alive. What is wrong? I don't have a modifier. I think one thing that is happening, and this is the same. If you've been following, you would understand what I when we're talking about the pigeon. But let me address this. I think one thing you have to do is first off, run. You have to. That is why I started with running the packages. They're now importing them. When you have them imported, then you cannot continue to run again from the start. Because if you don't do it like that, then you continue to get error. Come on, like mine is NLB. The NLB model should still work. Okay, fine. Let me run mine and see. Let me run mine and see. So if I run this, yes, then I run this. So Diamond, so you would have to, like I said, it's only going the model, machine translation for PG will only do well when it comes to like anything that has to do with science or biology. So you have to structure your prompt. We cannot ask questions, right? Because this is not like text generation. This is not a text generation model. This is a machine translation model. So you cannot ask questions. Basically, what these models are to do are to translate whatever I'm saying to like a target language that I set them for. So I'm running the NLP again just to show us that yes, there is no issue. Please, we still have to go to what we have for today, which is tokenization. Why not copy and paste? I'm sorry, Abubakar, what do you mean by why not copy and paste? Like, can you explain? What do you mean by that? So I'm running this again. Yeah, yeah, yeah. So hello, okay, let's see. So I don't have any issues at all. Like you can see, it's there are no errors. There are no errors. Come alive. And whoever is having issues again with the NLB model, there are no errors. Like I said, you have to first off, you have to first install the package, then import them. If you don't do that, then it will not work. Then of course, download the model itself. Let it stay in your CUDA, that's your GPU. So please, there are no errors at all. It's working well, it's working fine. I didn't change anything. I didn't change anything. So Dmax, are you still having that error? Dmax and come alive, are you still having that error? Abubakar, what do you mean by why not copy and paste, please? So I did not modify any. I'm still using the same notebook. I don't modify. If I even modify, it's going to be in class. I don't modify outside the class. I basically don't touch this notebook after I'm done with our sections. Then I come back. Very wrong to still probably the internet. But are you sure? Are you even sure that you connected it to the GPU? Sorry, come alive. What do you mean by what do you mean by what you just pasted? Because you are literally pasting the same code. You are not pasting the output. Oh, Apaka, if what you mean by why don't I just copy and paste the sentences that have been typed? Okay, oh, okay, yeah. Why don't I copy and paste? It's because I'm logged in on YouTube on my phone. I'm not logged in on YouTube on my laptop. So I basically just, read comments from my phone and and I, I read comments from my phone and I type, right? Sorry, that's what I have on my own. Why do you have pigeon on your own instead of why do you have pigeon on your own instead of the above? No, I don't. Everything is all in the notebook that was shared. Please, you have to go through it again. Go through the notebook that was shared. This is for pigeon. I think let me just put like a text, a markdown. Translation. So that states. So that differentiates that. Let me just continue to try the prompts that were shared. Please, I think after this, I'll have to increases when temperature rises because the particles gain more energy. Um, collide more frequently. And collide more frequently. So let's see. I like this. Okay. So I got something wrong, right? So what's wrong? Now, okay. Now the rate of chemical reaction they increase when temperature they rise, when the particle go gain more energy and fit cost more frequency. So that's the translation for that. You guys can all test it out yourselves. Apologies, please. I just saw this below. Thanks. Oh, you just saw it below. Okay, no problem. I use my statement and it translates it for me, Manuel. Sorry, I don't understand what you mean. So come alive. I hope that has been cleared. Okay, so guys, let's just move into what we have for today. Let's just move forward to what we have for today, please. So basically, today we're just going to be looking at tokenization for multilingual models. I mean, especially when it comes to like for machine translation. No, I talked about how uh the tokenizer has to first, tokenize the maybe the source language before it now start, then convert it to like tensors, then before it now start converting before it now start generating new tensors for the targeted source, then now start tokenizing it again and all that. So it's all a process. It's all a process, right? So now, I mean, what is tokenization? We're all familiar because we've been talking about tokenization. Convert raw text into tokens, subwords, and pieces. Common approaches of tokenization, we have the byte pair encoding and we have the sentence piece. For a large part, we'll be using the sentence piece. So sentence basically has just been breaking the tokens down, right? Then the byte for a large part we'll be using this throughout. I have to close this. We'll be using this throughout. And for multilingual models now, shared vocabulary handles many languages. So, like, let's say for this machine translation model, so most of the times, right, what they do is to generalize the token. Especially why that's why some of us when we're trying NLP, we're getting very funny translations. I remember Olajumoke when she said she was getting very funny translations. Sorry, I need to. Okay. When we're getting very funny translations, right? When we tried NLP, and it's because most of the times it's either they make use of maybe shared they make use of maybe each languages are maybe they kind of map maybe similar languages that are written alike, then they use a particular kind of tokenization and they generalize it. I think for us, maybe we are using the Latin tokenizer. That's why we have that underscore Latin. I'm not sure. I'll have to check for NNLB. And that's why sometimes the language, the translation can sound very funny. I'm not sure. I'll have to check. I have to check the tokenizer. I was supposed to check, but I got occupied. But I'll check and I'll get back to us on that. So tokens might look like pieces of different languages all mixed together, as simple as it is. And why do tokenization even matter? Because they affect how the models use morphology and real words. So how basically morphology, like how the sentences are being set, how they are being formed in quotes. Then and also maybe the model has not seen a particular word, right, during training. So how will he now know that okay, I'm supposed to generate a translation for this? Then so it really matters how tokenization works. Initially, most of the times we train our own tokenizers, right? We train our own tokenizers, but that involves like a lot of data, so to say. And good tokenization can improve performance on low resource languages. We've said this. For a fact, the languages that we have, that's our Yoruba, Igbo, Hausa, they are regarded as low resource language. We spoke about why they are called low resource languages. Low resource language in the sense of that we don't have a lot of this data available in public use. Like they are not well documented in quotes. So we regard to them as low resource languages. And I spoke about how it's like a budding research area, and how researchers are trying to see how, especially people that are doing linguistics, right? People that like have interest in computational linguistics, trying to see how we can. The Microsoft, thanks, sir. Okay, no problem. Trying to see how we can improve you know these models, to have our own language and generate them well, and also in terms of for language preservation, to preserve our heritage of language. I don't really want to go into depth of how all this matters, but please, they do matter. So let's say now that we're working with NLP tokenization, let's see how it works. Let's even see how NLP tokenizes English language. So I have this function to show tokens. I just want to see the tokens of how it generates the token of language. Then I'm using the NLP tokenizer, wrapping it in my text. Remember, this is my text. Then translate this to the local language that I've already set. Then that's the local language itself is like my target language. By default, I have the Yoruba. I have the Yoruba itself. So I'll run this. Then I want you to print the tokens, print the number of tokens. And yeah, so if I run this now, I'll see this. And remember, okay, now this is it. This is what I'm trying to translate in English. This is a simple sentence for tokenization. See how it generates tokens, right? This is a simple test sentence for toke, then king. Most tokenizers will even break this sentence. They will break even this simple. They will break it as simple. It's just like how what's the word? I'm trying to look for the English definition for this. Sorry, getting messages here. I is supposed to translate English to unknown tongue as in the Bible. As how now? Mr. Bash, I would like to know if it is possible to use other models from Hugging Face to test in our local language against your fine-tuned model. Definitely, please. And there are even also better ones that would perform well in Pidgin, for sure. While this one just does well when it comes to science. When it comes to anything like scientific, it does well. Like I can say for a fact that it does well. Interesting. I was supposed to write a paper on this, but I think my friend who got the data, who did the old data, she wrote a paper. So I'll try to check on her paper and see if I can share with us. Syllabus. Thank you very much. Syllabus. That was what I was looking for. Syllabus. Yes, syllabus, please. Thank you very much. Thank you very much. So yeah, you can also check for other organ. Like let me even search. There should be pigeon. So you can see other models for pigeon. This was even fine-tuned on Gemma, small fine-tuned on pigeon sentences. There are a lot, to be honest, a lot. I mean, I'm even proud when my own comes up. My own even comes up when like in the search. So I think I'm proud of myself because interestingly, I just did this as an hobby, right? I just did this as an hobby, but there are other ones like if you just click, you would see other ones that have been done. See this one now. This one is even a TTS. This one is even a TTS. So this is for audio. I was supposed to have actually like improved the model card. So yeah, like I mean, there are a lot of there are a lot of models you can test. This is for voice. This is for this Gemma. Let's see if it's for voice. Okay, this pidgin language trained peer-to-peer conversation. Okay, so oh this was even done with onslaught. Oh nice. So yeah, I mean there are a lot. This was done with Gamma. Gamma is Google's small language model. So we have large language models, we have small language models. Small language models are basically they I mean we consider smaller parameters. It's like smaller data set. Might not be like they are not small in that case, so they're actually pretty large, but not as large as a large language model. And of course, like and we just consider like smaller context window well when training and all that. So and they can easily be deployed. Reason why is because you just need a very small computer to be able to deploy them, right? Like ideally, an 800 should be able to run a gamma model easily, a gamma model easily. So yeah, let me just go back. So explaining this, you can see how it breaks it into syllables. It's just that for the machines now we talk about even the how it tokenizes full stop. It's all there. Then how it even translates, how it even breaks down this. Okay, translate to Yoruba. You would see it right. How it breaks them down. So I mean that and the numbers of tokens are being generated. So that's how that works, right? That's how that works. And I mean, as simple as it is. Sorry, I think this was supposed to. Okay, it's all good. It's all good. It's all good. It's all good. Oh yeah, breaking down into the language name into Yoruba. So you see how it even breaks down Yoruba. So yeah, each models have how they break down they break down they break down sentences and how it helps to now convert all this into tensors, into numericals in quotes. I explain what tensors are just arrays of numbers. And yeah, that just that's how it works. So we might not need to. We might not even need to. We might not even need to go on break so that we can just finish up all this. Let's just finish up all this. I just want to be okay. We'll soon finish. So I don't need to go on break. So we'll just finish up all this in time, and we can go back and I mean, right? So let's just continue. Then this is just like an exercise for tokenization exploration. Try different sentence, short versus long, formal and informal, just to see how just to observe how these models actually like how the tokenizers actually work, right? And we can keep on. These are the texts. You can change it. You can change it to any word. You can practice on this. It's just like a to do. You have that on the notebook. So if you're actually running this through your computer, you can just run this, and you would see text makes your customs. You can see how it is breaking down all these sentences and the counts. So basically, this is like its own in quote syllable. This is like its own syllable and all, right? So yeah, that is that. Please, any question? Any question? Any question? Any question? I mean, there are no question. If I can just get like an indication of no question, then we'll just continue. Any indication of no question, we'll just continue, please. Okay, so since that we don't have any question, no breaks. I mean, I want us to let's wrap this up on time. So we'll don't worry, we'll close on time. We're not going to take any break. We'll close on time. Right. I just want us to no question. Okay, no problem. So for the break, let's just finish this on time. So we'll close on time. Right. Okay, so this was just like a small to do for us to, you can still play along with it, change these sentences, change it to whatever you want, like just try to experiment on it, right? Just helps your understanding on how tokenizers work. So sir, if I change your model, do I need to install a new package or something? No, because you already have that. Basically, what you're doing on Jumoke is just to download my model. So basically, you don't need to install any new package because the default packages are already there. That's for the transformer, the the tokenizer that is there, the the PyTorch too. Everything is all there by default. So you can you can um you can also like change, just remove my model and replace it to any other model. That should work. I thought it was supposed to translate the sentences to Yoruba. Sorry, Dorcas, what was supposed, is it the tokenization you mean? Any other Olajumoke, please, do you understand? You can just indicate, please, if you get what I mean. Oh, okay, thank you. So, model selection for translation. Interestingly, now this is like me even. This is what we're discussing about, right? How do you even select models for translation? So, what basically are you to consider when you're even selecting machine translation model? Yes, or did I get it wrong? No, no, no. It's just to show you the token. It's just to show you the token, so to say. Yeah. So how do you select a translation when it comes to when it comes to how do you select models? Sorry, how do you select models when it comes to translation? So things you should consider when choosing model: the languages that it supports, the model size and speed, smaller, faster, cheaper, less accurate. Like you can see, NLB 600 million parameter. It's faster. We generate languages faster, but sometimes it's not really that accurate. Like I told you guys, if it was the 3.3 billion parameter, we'll get accurate model. Language size supported. Now, okay, let me show you guys something. See now, you can see this German. Now it takes in Pidgin. That's why you have Pidgin here. I just want to use Hugging Face to be showing us how all these things work. So if I go to LLB, I go to this. Okay, let me see. Open distilled. See the languages that it supports, and see the number of parameters. And it's a distilled model, right? So it is lightweight. If I click here now and I see the numbers of I will see. I can see the amount of languages that it supports. Can you see all the languages it supports? So that's how you'll be able to know. So it's more than just having to just go somewhere and pick up a model to use. You have to know, does that model even fit what I'm trying to translate? Right? Does it fit what I'm trying to translate? Also, what's the word? Is it lightweight? Can it run on my GPU? Can it run on my system compute? So these are like the kind of things that you have to like factor in, right? These are the kind of things you have to factor in. And what else? Okay, let me even show you us. So let's even see the model card for the bigger ones, the big dogs, like the 3.3 billion parameter. So I mean, if you had good like large compute, right? I mean, you can use this, and you get accurate translations. So yeah, you can test run this. If you have access to large compute, you can actually test run this. So domain and style. Like now look at it. General web text versus legal, medical, and technical. Now you see that for my Pidgin data sets now, it's really just doing well when it comes to scientific translation. That's for the Pidgin model. It's doing well when it comes to scientific translation. So you see that, I mean, it's giving you very accurate stuff. But when it now comes to like very general things like, okay, hello, how are you? You see that it now begins to generate, let's just say, literal jargons, right? It now keep on generating literal jargons. So depending on the kind of translation tax that you are doing, right? You want to consider, oh, that model translation now, will it perform? Of course, if I'm doing things that have to do with domain specific stuff, like things that are kind of medical, for legal, for agri, depending on the sector, and I use a model that has been trained on those kind of things, it will perform better rather than a generalized model would do. Right? Do we understand that it will perform better than that? So these are considerations you have to put into when you're selecting a model. So I think I am Olajumoke. This is like giving you like things that you need to consider, especially when you want to select models. Right? So this is giving like an overview when you want to select models, how they would be, how what you should consider. So now again, when you pick the general ones, okay, no problem. So things that you have to consider, like your GPU. When I say compute, I'm just really talking about your system RAM. Basically, I'm talking about all this, right? I'm talking about your system RAM, your GPU RAM, your system storage, all that. Like those are computes per se. And I already explained that you run all these things, you run all these models on GPU, on computers, and we explained why we even use GPUs rather than just CPUs. We've already explained that, we already established that. Now, if you now want to run like models, now you have to consider, I mean, language supported here. Now, model size and speed. The larger the model, the more accurate you get. The larger the model, the more accurate you get your response, your translation. But it will be slow because of course it's trained on a very large corpus of data, and a larger context video, a larger parameter has been considered. Compared, like I use the case study of 3.3 billion, and it is still 600 billion parameter LLB model, right? I would have loved for us to kind of do like a demo to compare and contrast 3.3 billion, 600 million, the model that the translation of a sentence that has to do with 600 million parameter, 3.3 billion parameter, and we now put it side to side and compare. But it's just that the 3.3 billion might not my T4, because I'm using a T4. The T4 model will not be able to carry it. How do we know the model size? Very simple. When you look at the model name, can you see this? LLB 200, LLB 200, 3.3 billion parameter. Basically, that is it. That's how you know the model size. Another way that's just like a key indicator of how you know the model size. Another way you can know the model size is just to maybe go to the file and you see it, you see how large it is. See the tokenizer JSON. You know what? Let me try, right? Let me even use this. I want to experiment. I want to see if this will carry. But now we can see how big this is, right? We can see how big this is. This is 6.3 GB. These are like the model bin, and you can see how large they are. Now, if I go to NLB, which parameter is considered small or bigger? This is what this is basically what I've been saying. Smaller ones will run faster, but might not give you a well accurate translation. Larger ones will give you very good accurate translation, but might be slow. That's why you see now for Distill, you see that a lot of people download Distill because it is lighter, it can run faster. Right? Now let's see the size. See how light it is. See the beam, see how light they are. You know, they are just very light. Please, let's compare. Choose the one that our Tifo. So yes, I want to see the 3.3 billion. Even if I kind of don't think it should go well, but let's see. I don't think it will go well, but let's see. Right? Let's experiment. So what I would do is just replace this. Sorry. Replace this where I have this. Paste my 3.3 billion LLB model. I'll run this, then I'll run this again to download the model. Let's see. Sorry that I had to minimize, but now it is downloading. It's downloading all the model bin. Basically just downloading the model. You see that it's going to take time. I mean, we might literally sleep here. We might literally sleep here. See the amount of things I have to download. I hope we're seeing this. So all these things are what you want to consider. The 600 million was fast, and we just got it, you know, as soon as possible. Now this might take a longer time because I mean, I don't know how long we are going to be here, right? But let's see. At least we get the gist now, right? right? Oh, please, I hope you get the gist. Can we react? Can we react just for me to know that yes, we get the gist of things that we really need to consider when selecting models. Can I see reactions? The bigger one there, okay, yeah. So I mean, the bigger model is still downloading. It's still downloading. So let's see how that will go. But you could test it out, right? You could test it out. You can compare the translation. You see how it is better and all that. So yeah, please, I hope I hope all this is making sense. I hope all this is making sense. Okay, okay. I hope all this is making sense. Oh, okay. All right. Thank you very much. So, I mean, I might not be able to run any other code since that one is still downloading, but I'll just be explaining. I'll just go on and be explaining. Okay, now I think I didn't talk about. Okay, now I hope you understand that domain and style, that general web test versus the ones that are versus legal, medical, and technical. I hope you understand, like maybe when general data set has been used to train a model versus when it is now nuanced to like specific domains. I hope you get the gist. Okay, all right. So now, I mean, don't worry, we're already getting to the very interesting parts. We're getting to very interesting parts already. So we also have the deployment constraint. Now I want to be able to deploy my maybe I my own fine-tuned model, or I want to deploy the ones I'm even having. Now I have this model on my now I have this model on my what's the name now? I have the model on my compute here. But now, what if I want other people? I want to deploy it on a web server, right? And I want people to actually make use of it. How would that go? So I have to now consider, okay, do I have like does it want to be on device or on a server on the cloud? Latency requirement, latency, like when it's generating like an inference, like an output. Learn with Bookie. Sorry, learn with Bookie. I don't understand what are you reacting to no for? Learn with Bookie, what are you reacting to no for? Okay, so I'll just go ahead, right? So so in latency, so you want to consider, okay, now heavier models, it's likely that latency will happen because it will take time before they generate an output. It will take time before they generate an output compared to like very lighter model. Yes, the output might not be all that accurate, but I would know for sure that whatever I am generating will render faster. So all these things are what you have to consider. So now in Hugging Face, you often have to choose between dedicated translation models. Like now, I spoke about like models that are maybe they are just for Yoruba themselves. They are just for Yoruba. They were just made for Yoruba. Compare them to LNLB that was made for what's the name now? That was made for larger data. Larger languages, so to say. Well, trained on larger data. So those are the kind of things you have to consider, right? Those are the things you want to consider. And also instruction based model, like you have to kind of, because they are not, how do I put it now, they are not kind of built to, just like instruction models now, they are not really built for translation, right? They are just like your typical LLMs that you, or SLMs that you just have to first tell it with a prompt like this, translate this sentence to Yoruba, then you provide your sentences. Now, over time, instruction models might not really give you something very well, might not give you nice translation, but compared to something that's been dedicated, compared to a dedicated model that is for Yoruba, you know that yes, with that you are getting Yoruba translation faster and and easy. And when it comes to like massive multilingual, I mean, of course, because that massive multilingual models now, they have to do with larger language that might be using similar tokenizers and all that. The translation might not be as accurate as maybe just using a model. Sorry, apologies. Let me quickly check on what on the heavy model. Okay, now this is it. Now it has. Yeah, I think so. You can see that it really took time, right? It took time executing. So it really took its time. So now we now see what heavy models I mean, they take time to actually actually download and all that. But I just want to be able to show us. I just want to show us how they perform. Let's see the improvements. Sorry, let me now go back. Once it's done running. So compared to a dedicated model, because it's only for Yoruba, it's only for translation from Yoruba to English, and we'll see how it performed. This was even fine-tuned on MT. Let me check this model. I want to check it on Hugging Face. Let me see what the model is all about. Although I think this was done by Professor Adelani. This must be Professor Adelani's model. Let me check. Okay. So you see, this was just this was just built with what's the name now? With just Yoruba, and it was okay. It was even done with T5. This was fine tuned with T5 model. It was done with T5. This is it. It was done with T5. It was fine tuned on T5. Yeah, you can read on the model card. You can literally see. Hey, it was done by Professor Adelani. Professor Adelani is a when it comes to computational linguistics, when it comes to languages, he's one of those guys that are that are the top guys, and the top guys when it comes to LLM for language, like for low resource languages. Also has a community called Masakane. You can check them out. You can join the Masakane community. You would see like you see faculty members, researchers, that are actually playing good that are actually doing well in this area, in this space. Please, I hope we are following. I hope we are following. See now, if you notice here, my RAM is already peaking too. This might even crash my RAM because you can see that it's trying to render this to my RAM, and I'm already having a 7.7. Oh, interesting. I think it's done running now. I just see the space I have in my RAM. 14.7 out of 15 gig has been used in my GPU RAM. So you see, you see why larger languages now, sorry, larger models now, you see they are compute intensive. They are compute intensive. Let's see if that's done. I imagine I got an error. See, this was very much expected. CUDA out of memory. Try to allocate 64 MB. So it's trying to say that there are no more capacity. So try a smaller one. So you can see that the T4 cannot contain. So you see that the T4 cannot contain the larger model, which is this. So I will just replace it back. That was just to show us how. So that was just to show how big larger models can be. So I mean, for us, we just have to make use of the smaller one. Yeah, okay. So I will have to disconnect and like delete my runtime and just continue. Disconnect, delete, restart section and run. Oh no, no run all, please. Just restart my section. Restart section, yes. So that will just make sure that whatever I've downloaded here just goes back to zero or not. Okay, sorry. I think I have to restart section. No, yes. So everything I downloaded has gone back to zero. So now I can now, now run the code again. Let me just install the necessary packages that we'll be needing just in case. But I mean, if you have access to larger compute, you can try it out. You can try it out and see what works. I could easily use, like, I don't want to use something that everybody will not have access to. So I'm trying to make use of something that everybody has access to and can run and see and use by themselves. What inside can we use larger models and smaller models? Like I said, it all depends. It all depends on the tax. I already explained it in the notebook. It depends on the tax. It depends on what you're trying to achieve. It just depends on the tax and the resources basically that you have at hand. So yeah, those are things you really want to consider. Okay, let me just go back and run this. Okay, let me go back and run this. Please, any other questions? Any other question? Oh God, my eyes. Am I sure this is already here? Let me check. Oh. Please, any other question? Okay, let's see. Let's be sure if we already have it downloaded. Okay, yeah. Please, any other question? Anybody has any question? Okay, so I'll just go ahead with what we have. We're also going to be done, please. So now I'm making use of this T5 model that has been trained on Yoruba, right? And what else? What else? What else? Okay, yeah. So now you see that it would even perform better. It will perform better than a a translation from NLB. So now if I run this, oh okay, so just to explain the code, right? I mean, so you just set your small model. This is it. Then set to true. Then small translator. We're not using, well, basically set it to none. Then text to text generation. Yeah. So this is just the pipeline. Then the model we're using. Then set to CUDA. Take this off, please. Then set to CUDA. Then just set our debug message to say, oh okay, it should load my model. If it could not load, raise a bug, oh, sorry, raise a debugger on Y. Then okay, then I'll just skip it, skipping small model. So it all depends. So I've set it now. You can see that it has loaded my model on CUDA because I already set it at device zero if CUDA is if sorry, device zero if CUDA is if device is set to CUDA, which is my GPU, or minus one, that's if it's set to if it's set to the CPU. Let me just put CPU. So yeah, we already have that. Now, this is what I am trying to I'm trying to translate. Hello, how are you? Generated text. So if I, you can see
Hello, Bawoni. I'm very sure. Sorry, apologies for my Yoruba again. I'm very sure that you see that this translation is better than what we have with the NLB distilled. 600 million distilled. It's better than what we have with it, right? We would see that it's better than what we have with it. So, you can now see how smaller language work. Okay, now we even have this one to even compare the smaller language and the larger language. So let me run this now. Let's see. So I run this, and basically this is just trying to like set the just to load the small language model. Then this is the sentence I want to translate. Whether it's very good today, I'm not going to the market. Then the source of sentence, then print for NLB, then print the one the NLB translate, then print the one that our small model translate and all. So let's run this now and see. Let's compare. So this is the NLB model and the small model all put together. I don't know if someone that can read Yoruba, can you compare? Which one would you go for? Which one would you go for literally? Let me zoom out. Which one would you go for? Um what are really the features? What are really the features to restart a section? Basically, restarting a section is just basically trying to like, you're kind of you're erasing the memory. You're erasing the memory of what you've done before, and you're not trying to like run another. You're trying to raise like you're rebooting the system in quotes. Yeah. Also, Shegun, NLB translates is better. Okay, smaller model translates better. Interesting. Olajumoke, if you're on the call, sorry, I'm calling you out. I mean, you called out my Yoruba. So please, which one would you say translates better? Which one would you say translates better? Anybody else? I need more suggestion. Which one would you say translates more better? Like, which of the translation do you prefer? No, two. Okay. Oh wow, NLB did it better. Small. ah, we need to come to a consensus. It's like everybody just have preference of what they want, of what they are looking at. Okay, NLB smaller model did it better. Oh, interesting. NLB did it better. Okay. Okay. You know what? Right. Let's smaller model as a typical Yoruba boy. You okay? Okay. Okay. Let's see. Okay. You know what? Let's change the source. Let's change this our sentence. Can someone give me another sentence? Please, it doesn't have to be Yoruba. You can change the source language to Igbo to Hausa. Play around with it, and all. Try to see what works, what does not work, and all. Please, can someone give me another language to translate to Yoruba? Let's compare again. NLB consider the what the NLB is like KGV translation. Why small model did let's say NKGV. I tell you, LLV did better in the sentence. So interesting. Small model did not include today. Okay. You can use God is good. Okay, let's see how we translate God is good. Let's say how I translate God is good. Okay. Okay, look at Ọlọ́run dára, Ọlọ́run jẹ́ ẹni rere. So you see the difference, so to say. So which one would you say translates better? Which one would you say translates better? Let me highlight. Which one you say NLV? Okay, NLV. Small model. NLV is better at the first one. So NLV for every action. Okay, oh, please, this for every action. Are you trying to say this one I should translate? So smaller, small mode. So it all depends. So I think now, I think the machine translation is kind of relative. The output itself is relative to what we want, right? I think we can say that. Okay, okay. So, and remember that it all depends on how these models were fine tuned and the use, so to say. Translate pidgin to Yoruba. Sorry, translate Spanish to Yoruba. You know what? I give you. You have the code. Top easy. You have the code. Do the translation yourself. That's an assignment. Do the translation for yourself. I'd also say when I think level of individual knowledge, I think we also need to consider the level of individual knowledge. Yes, actually, we should consider that, to be honest, because it's how it will now sound, very typical to us. Yes, 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 yes. So I mean, for every action there is equal and opposite reaction, Newton's law. Okay, please use. I sorry because this is not science. Let me still use this. God is. Let me use a small one. God is the creator of all. Okay, let's try that. God is. Wow, interesting. The smaller model hallucinated. The smaller model hallucinated. See what it generated. Interesting. It did not generate something. It did not generate something useful. So I think we will give it up. We'll give it up to. We'll give it up to NLB. Okay, no problem. We'll do for every action equal, and opposite. No problem because we've been raising this for a while. Yeah, we'll do that. So, uh, to every run that one more time. I actually did run it one more time, and I mean, it still did not go well. There's equal. There's equal and opposite. Oh, sorry, and opposite. An opposite reaction. Newton's. Newton's. Okay, let's run this. Let's see. Let's compare. Let's see how it performs. Fún gbogbo ìgbésẹ̀. Okay, so let look at the smaller model. Although I don't know how I'm going to zoom it so everybody can read. Let me see. Let me zoom out. Let's see. So this is it. Nope, nope, nope. No, no, this is for default. Sorry. I cannot really zoom out for everybody to see, but this is how it is coming. This is how it is coming up. This is how it is coming up. So it's basically too long for us to read for the smaller language model. So it's obvious NLB is better. I experienced the hallucination with the smaller model. I think NLB is better. So yeah, I mean, there are other languages you can consider. See, just go on Hugging Face, right? I mean, go on Hugging Face, search Yoruba, see different models that you can experiment with, just to compare and contrast. See different machine translation models you can compare and contrast with, right? So yeah, so yeah, I think that brings us to the end of today's class, right? And I hope it was an interesting one. I hope today's class was an interesting one. I really hope we got to understand, how all these models really work, so to say. I hope we understand how all these models, they tend to work, so to say. And I hope we understand. I hope we understand how all these models, they tend to work. And of course, we understand tokenization too. The importance of tokenization, the importance when it comes to selecting a model, all these things, right? I hope we already like now have cognizance of, when it comes to selecting models, what to consider, especially when we want to build our own translation model. Again, we should start looking into, I want to see people pick up independent projects, maybe machine translation projects, maybe build a tool, right? And please read up the paper, you know, read up the paper, because we're going to do an assessment. And trust me, I can bet you that from my own side, though, right? From my own side, I would set papers of that assessment. I'll set my assessment will be based off those papers, those things I gave you guys to read. It will not even be based off most of the things we do practical. It will be based off those things we read. So please read them up, right? Please read them up. Read them up. And yeah, so thank you very much. Tomorrow you'll be meeting with Jumobi. Uh, you'll be meeting with Jumobi. I need to take care of my eyes because it's really a lot, and I need to stop staring at screen because I've really strained my eyes. So, thank you very much. Um, take care of yourself. Take care of yourself. Right. So, bye bye. So, thank you very much, guys.